The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dan DuPont of HawaiiTracker.com, bringing you guys another Hawaiian Volcano Tracker update. Today is Thursday, March 23rd, 2023, and both of our volcanoes on Hawaii Island are quiet at the same time once again. Kilauea and Maunaloa, both in a little bit different ways. Maunaloa is quiet and not doing any shaking. Kilauea is quiet on the surface, downgraded, but still quaking quite a bit actually. How are you doing today, Dane? Ooh, we're back to the swing and miss.
Yeah. Just taking all in, the trying to figure out the timing on Kilauea, right? That's kind of what it's all about. We know, lava's going to return. It's all a question of when and how soon and things along those lines. So yeah, we'll get into that and touch upon Monoloa as well, but yeah, it's pretty much quiet.
Yeah, so yeah, we'll cover the bases as usual. Depending how long it takes us to do that. Well, I won't say that it will take us any less time than usual, but we'll see.
Might be a short one, who knows?
We always find something to talk about. It's always
the ever elusive one, right?
And then if you guys have got questions, by all means, add your questions to the chat. They're going to be leading a discussion on the chat and also collecting questions for us to discuss on there as well. So anything else, Dane, before we get into it?
No, I think that's it. We'll go through it and just get the questions in and we'll try and address them.
All right. I think your camera might be a little lower than usual, just so you know. But all right, we'll get it going here with our Hawaiian volcano summary. And All right, so this week's Hawaiian Volcano summary. You guys are seeing on screen an image of the thermal camera from Kilauea, courtesy of the USGS HVO. And this is what the infrared or the thermals look like for the last week or so, right? Only a little bit of glow coming from the west vent complex. That's down in here. But the area that had that most recent lava lake, that west basin right over here, is all the way cooled off. It hasn't really shown much change, and there's not much to show you visually for the last week. We can show you is this is the GPS distance north to south across the caldera. This is for the whole last year. So we really want to focus in on this very last part here on the right. And when this line is going up, it's showing the caldera wall north and south getting further apart. And what you can see is that it's been doing that for, this is about the last couple months or so now, or maybe the last month or so maybe. So a couple months or so, a month and a half. So what you can see is that the underground adjustment of the volcano is stretching out, right? It's stretching out north to south, and it seems like on the south side might be rising a little bit when we go and look at the detailed data there. So the GPS catches a deeper signal all the time. The tilt meter doesn't always. However, the tilt meter for the last month shown here is also showing this commensurate increase in tilt. It's hard to tell as easily because you have a lot of these deflation-inflation cycles that are part of the background movement of magma within a volcano. So within here we had this larger inflationary signal that led to a small intrusion event. But the overall pattern is that despite all of that, the baseline seems to have come up and is higher now than before. So both in the shallow regions and in the deeper regions, as shown in GPS, we're seeing the volcano filling underground. And here are the earthquake counts for the last month. You see in that same period of time where the tilt had gone upwards and the baselines increased right through here, these last couple weeks, you can see that our average earthquakes per day, which is what we're looking at here on the left, might be somewhere around 50 or so, somewhere in there, right? Sometimes a little higher, sometimes a little lower. The previous 2 weeks before that might have been half that rate. We'll draw it at 25 right in here. You can see how that's more or less that baseline prior to the pausing of the volcano there. So this is really showing that pressure is building underground. It hasn't quite spiked to levels where it might lead to a surface breakup, but that could happen fairly quickly. And so this is the most important combined signal here, is the ground movement and the earthquakes together. However, because on the surface the volcano has paused for some time now, the USGS has accordingly lowered the alert level from watch to advisory and color code for aviation from orange to yellow. But noting that seismicity and deformation patterns remain unsettled, resumption of activity may occur in the near future with little or no warning. Potential remains for resumption of this eruption or initiation of a new eruption at or near the summit of Kilauea. So that is the long and short of Kilauea. Monoloa, we don't have any imagery to show you, but this is the tilt plot for the last month. You can see that it also looks like it's showing some inflation as well, and this is normal for the post-eruptive pattern on Maunaloa, so that's thought to be normal. If we look at the earthquakes, however, here's earthquakes per day once again. This is now, up top of the plot here is 9, and this is 0, so you can see that some days there are no earthquakes at all in that summer region of Maunaloa, and some days you might get up to, well, less than 10 no matter what. So a lot different story than Kilauea. Even though you have the inflation, you don't have any of the earthquakes. That's the big difference there. If we zoom out on Maunaloa for the last year, that we were just now looking at this zoomed in section right in here. So we're really in a background level following the eruption, which was this big signal. Really right in here was the eruption signal, and this was the build-up to the eruption that came a few months beforehand. So even compared to a year ago, you can see we're at much lower background levels, and Maunaloa thus is normally quiet. And that's a summary for this week.
Oh, sorry. Sorry to jump in there. It looks like we did have the information come through on that earthquake that we had a little while ago, and it seems to be preliminary reading at a 4.1 on Monoloa with a depth of 4 kilometers. So that's interesting.
This is the one that I just, right before we came on air, I told you I felt an earthquake?
Yeah, that one. Yep, 4.1 Monoloa.
Oh, interesting. So we'll come to that as well when we look at the earthquakes in Maunaloa. So there have been a few on the flanks. This little plot is actually capturing just that summit region. We'll get into that here in our more detailed walkthrough now that our summary is done. So let me switch our label here to our Kilauea observations, our practice of observing Kilauea, and we'll start with this KW camera up on the west side of Kilauea caldera. Day and night here. I'm keeping the night in so you can see the darkness in there. It looks like we're having something happening with the lens there. It looks to me like it might be moisture that got into the housing, because you see it's distorting that focus for a while there, and then it seems to evaporate and be gone, and now we're back to normal. So there's been quite a lot of moisture recently and a lot of wind, so I'm not sure if something failed there or if it's been repaired or exactly what happened. You can see that most of the rain actually came through yesterday here at Kilauea Summit, and here's the end of our last week of video. So that is the what happened there. All right, Dan, I think we'll put us here on a screen. I'm not sure what happened to my browser. It might have crashed on us. Let me see what's going on while maybe you can help me fill in here.
Yeah. So just looking at this earthquake right now, I'm trying to write a little something up on it. Looks very close to the eruption site that we just had. It's a little bit south of the rift zone, and it seems like there was a quake in the same approximate area earlier today, around noon, around 1 p.m.
All right, I did see that over there. So, all right. So what I'm gonna do is I'm just gonna totally switch our order here. Let me see if I can get the earthquake label on here, and let's look at the earthquakes since that's what we're talking about right now.
Right.
All right. So with the earthquakes on the screen, start with our recent earthquakes. Things that just happened kind of threw us off a little bit as getting ready for the live to come on, and suddenly the desk starts shaking here. All right. So here's our most recent earthquake. It's on the south side of the rift zone on Maunaloa, and there it is in red. Preliminary 4.1 is being set at a depth of 4 kilometers. So it's essentially this kind of south flank of Maunaloa that is still adjusting to the eruption site here. And what we've seen in recent data is that most of that inflation is happening mostly around the summit here, and the rift zone has been generally deflating. So it's not like it's not moving, it's just moving on opposite from the summit, since the magma came from the summit, went to the rift zone, and then erupted out of there. So the rift zone is kind of sagging, whereas it's recharging underneath the summit once again. So without knowing exactly the dynamics there, having these earthquakes in the flank is interesting. I mean, we know magma is coming into the summit and it's pushing the volcano around, and it also will have a chance to adjust, right? So we'll see what this ends up revised at. 4.1 is certainly something to be aware of. Looks like there's a secondary 1.9 popped up there as well. And here earlier today was at 2.5 in that similar area. So a little bit of earthquakes coming up here. When we're looking at that earthquake plot of Monoloa, we're really mapping out this area right around the summit in here or so. Right, so these are not considered as much of that signal for the summit. It's still interesting since we know that the south flank of both Monoloa and Kilauea do play a big important part in how the volcano can recharge and where the magma goes inside of it as it does so. So that's the Maunaloa earthquakes there. We have our cluster of Pahala as usual, still ongoing. Kilauea earthquakes are looking like they did last week, but we'll go into more detail when we get to that here shortly. And we have a smattering of other background earthquakes. There's a whole handful here up around Mauna Kea. This was a 2.0, we have a 2.0, a 2.6, 2.0, and 1.9, all kind of background events, not all clustered together, but fairly close in time. Still just adjustment of the volcano as it's settling. Imagine the south part of the island is moving and doing all this adjustment. The north side is more stable, but it still is going to have to adjust as well, not only from the forces coming sideways, but also the up and down motion is essentially cooling and contracting and settling back onto the seafloor, which is also adjusting underneath it. So all of that combined allows you to have those earthquakes. And sometimes they're deeper within that base underneath the volcano, 20 kilometers down, it's like 15 miles-ish. And sometimes they're a little shallower up in the edifice above, as that also has to adjust likewise. So that's the earthquakes, fairly normal this week, with one exception. We just opened here with this little Monoloa cluster that seems to be coming up. And so let's see here. we'll jump back to Kilauea, I think, and come back to our Kilauea observations. So let's get that lined up one more time here. And back to our, we had just looked at the KW camera here. And a little clearer, and since they zoomed it out, I'll show you guys the V1 camera. And I've taken out the nighttime since there's not a lot to see there. So just the daytime views of that inner crater area from the V1 camera. You can see quite a lot of fume blowing around still from the crater floor. There's no other action, other movement. There's a big rainstorm that came through yesterday. Caused quite a lot of steaming. But otherwise, no surprise there. You know, this whole area that we see crusted over here is underlain by liquid lava or magma. So not surprising that you see it degassing through all these different spots on the crater floor, and that when a rain comes, it puts out that much steam as well. And so that's all good observation, but all within a normal range. So there's not a whole lot else to show you visually today. We'll transition to looking at the main hazard, which is, as usual, the gas. So you see where the gas is coming from here within the caldera floor. But we'll move to our VMAP forecast, VOG mapping project from University of Hawaii. And we're emitting from Kilauea at a rate of 155 tons per day was the measurement in this model right here. And you see the VOG is drifting a little bit towards the saddle occasionally and a little bit down towards the southwest, Pahala, and towards Naalehu and Ocean View a little bit as well. Not as steady visible here. Having a low emission rate does kind of dampen that effect island-wide, but especially in a volcano area nearby where I am, you do have more of these effects evident as well. So overall, looking like a fairly good week with low emissions. When eruption does resume or return in some other manifestation, then we'll know it's going to get really bad at the start and then peter out from there once again. So we'll enjoy it while it's low for now. That's the forecast for the next couple of days. Looking at the Purple Air Citizen Science Monitoring Network, everything in the green today accordingly as well. So still pretty good air all around. We also like to check the national park, and here is a national park air quality page. Let's see if I can get this over a little more. And our summary is everything is in the green. The wind is not strong enough to be plotted as a directional plume here. Rather, they're showing it as a circle where it might linger in a summit area. That's usually got to do with the wind speed. So we're at 1 mile an hour or 1 meter per second, 3 miles an hour. That would be why. And so we've looked at this and we looked at the charts in the past here as well. If I click on the charts, it'll give us the measures if anything is in the red, and it looks like it's been in the green all of the last day here across the board. With the exception here of Uikahuna, you can see Uikahuna particulate matter did get into the red actually earlier today. Let's see what time this was. 10 a.m. got to unhealthy. At 11 a.m. unhealthy for sensitive groups, and then back to normal. Right? Prior to that was at the moderate level. So it is occasionally popping through here. Definitely follow the park guidelines if you're up in a park. But one thing that's been up for a few weeks now, and we haven't focused on it yet, but if you scroll down here on this air quality page, there's now this new link right there to the NPS Halema'u Crater View webcam. So the National Park is putting up a webcam. It seems like they're still working in it a little bit. I haven't seen like an official announcement. Maybe I just missed it, but they could also be troubleshooting this a little bit to get it all dialed in like they want. And if you click on that, it leads you to this page, and they have a network of webcams nationwide that they're putting out to help monitor air quality. So here is the webcam view. This is from the vicinity of, it looks like, Volcano House area-ish, right? So you're looking across this closer downdrop block that has still forested, and then the main caldera floor just beyond there. And looking to the southwest, there is that collapse pit of Halema'u with a fume emitting from there. So this is interesting how they have it set up. You have the webcam tab here. There's that air data tab with more of a tabular format for air quality. Coming back to this webcam tab here, we have at the bottom camera landmarks. So you can actually click on this and it'll show you more or less what is what in a landscape. It's not not one for one, but pretty close. And then there's a map it view as well. So this is showing you where the camera is positioned and its field of view as well, which is, I think, really awesome to see all this on here. So I'm back to the camera. If the volcano is glowing, you would see that here. In the nighttime, it's been all in a black though, however. So I would just show you guys a view here. This is back from the last 3 weeks or so, just daytime views from that camera, looking southwest to Halima'uma'u. And you can see that there are times where there are low clouds coming in front. That's not quite the same as fog, but occasionally the wind direction does shift and all that fume blows towards the camera in this direction over here. What we just saw on the charts was Wikahuna, which is up in this area more or less in there. And also get the wind going in that direction too. So this is a nice view to monitor what's going on there. So that last white out there was the rainstorm that came through yesterday. That's kind of a little tricky to just from the camera view itself. But the park does have other wind speed measurements, wind direction, SO2, precipitation, particulates all over the place. So that's how we can piece it all together. So one more resource. It's awesome to have this. We're appreciative that the park has this online. And one more tool to deal with our volcanic hazard here. Bottom line is less gas, so less hazard, but if you're close by, it can still be locally dangerous, right? So definitely watch for the signs and park guidance. Okay, so that's the hazards. We're going to put up our lava viewing report. However, the long and short is that there's no lava viewing right now. The national park has updated their webpage, what's going on at the volcanoes. And here is a summary. The eruption paused on March 7th. No lava or nighttime glow is visible from any overlooks. They can change at any time. And that's what we're waiting for, is for that resumption of eruption at Kilauea or new eruption. And then it's going to be spectacular for that immediate window right afterwards, and then probably decline over the following days and weeks, depending exactly what happens there. So just as we bring it to you guys and tell you like when it's epic, great viewing times, now we have to come and tell you there's actually no viewing happening right now. That's how it goes. So we'll move on from a report. That's the lava viewing report. And now we'll look at the Kilauea monitoring signals a little more closely. And starting off with this, just once again reiterating that Kilauea has been downgraded from watch orange to advisory yellow. I read this before, and there's really not a whole lot of extra stuff in here, but it's all well summarized. So lava supply to the lake ceased on March 7 based on lava levels and behavior of the crater floor. SO2 emissions have decreased to near pre-eruption background levels. Accordingly, they've lowered the alert level. Seismicity and information unsettled. Resumption possible with little or no warning. That's basically it. We're still getting daily updates for the most part. Looks like maybe there was one missed yesterday. However, today's update, no surprises here, not erupting, still in pause, no lava on the floor, no significant changes, and no unusual activity on the rift zones either. Got something, Dane?
Oh, no, sorry, I thought I was muted.
Okay. All right, so that's the report. That's the basics of it. So we'll look at the monitoring signals on Kilauea, starting with the Kilauea earthquakes. This is a map that USGS puts out from their internal data that sometimes has a little more information. This is colored by depth rather than by time now. So these blue ones are that deep Pahala zone. That's kind of the feeder area. The purples are in that area as well. There's one of those showing on Kilauea right here at the Upper East Rift Connector area. It's kind of below that. This is way, way below that. So this is the pathway that might come up and then reach the shallow parts, and then the rift zone is really in the shallow or upper part of the volcano here. Right, so this is not a rift zone earthquake, for example. We have the Kilauea cluster here at the summit, which you can still see is clustered within a collapse pit for the most part, but also to its south, right? And to the south, outside of the caldera, and still that seems to be the zone of the most action, which is interesting to me. We do know that we have the southwest rift zone that extends off in this direction like this, right? That connects, here's our summit zone right in here. We know we have our southeast rift connector right to here, and then the rift zone kind of turns off in that direction right to there, right? So that's our kind of rift zone and summit pattern. But as the volcano is spread, there seems to be somewhat of a break. This is these fault lines you see connecting right through here. That's the Kauea fault system, and this upper part of it, right through here, this little wedge seems to be that part that's being active and getting moved or compressed or pressurized in some way. And this would be likely, the most likely thing would be magma filling in the south caldera area and possibly pushing in that direction and causing those earthquakes. It could also be possibly wiggling its way into there. It's not quite clear exactly. We haven't seen any sign of that really convincingly, but the earthquake patterns may at some point suggest that. So that's interesting, that it might essentially be filling underground in some more complex ways that then probably would really matter. But it's all doing so in its summit region and not really transferring into the rift zone. That's the important take-home message there. We're still having some south flank earthquakes here south of the rift zone. That's all background normal. And we'll move on from the earthquakes here. So there is a 1 month plot that was shown before. And really it's this base level, and it's worth repeating how it looks a little elevated. Right? This is not crazy high amounts that we saw before that first breakout in late 2020 or even in mid 2021. However, we did see that intrusion just occur with not that much elevated signal right in there. So potentially you could have it popping at a lower threshold. It's possible. But also, if it does build up higher, it does seem like it'll get more and more likely than it is right now to manifest something there on the surface. So there is a tilt once again, deflation, inflation, with a baseline level coming up. Not quite clear if it's stabilized here at the top, right? It might have been that you had a flatter phase, an inflationary phase, and a flatter phase. Not quite clear exactly until we get more information. And the change in deflation inflation cycles here is interesting as well, right? The volcano there's a lot going on with a tilt there, and so it may be that it's trying to pressurize, but it's going through these deflation inflation cycles, and it's not quite doing so as fast as it might otherwise if it wasn't convecting inside and putting out this signal as we're seeing here. So that's the last month. Here is zoomed into the last week. USGS is on their daily reports noting like whether today is in a deflation phase or whether it's like in a steady phase, but I find that less useful than looking at the bigger picture overall of, you know, what's really going on, because as you can see, we might have thought every single inflation, okay, here comes, it might actually pop out, and then, okay, no, it's not, and here it is, nope, here goes, no, here goes, nope. And so at some point that gets a bit old, and you look for bigger signals. Like when I saw this one, I was like, okay, well, that's a little bit different. That might be something coming up. It led to the intrusion, but overall, these up and down little signals are not anything that you can pick out as significant, for the most part, as important as the base level here. And that's the really, really important signal that we see. So for the last year, now we're looking at earthquakes per week. Here's our last 2.5 weeks on the right. So you can see it's slightly elevated right here, what we had before, but it's not near our early January and late December time periods when it was actually maybe close to twice the rate that we're seeing right now. Right? So it may be that the volcano is pressurizing underground. It just found some small blockage and it popped that open, and it may still be pressurizing more and more and more and more, all the way to quaking at this level, right? And I have seen some reports and some people seeing signs of possible tremor down below. That's something that's not uncommon. On Kilauea, you can actually have magma moving from one spot to the other, but it's more about whether it's making it to the surface. This is not as straightforward as some other volcanoes where they're essentially dormant, not really doing a whole lot in between. And when you see that first tremor, that's your sign of, okay, something's actually different than usual and coming on. We get tremor in the background as well here in Kilauea from time to time, right? So that can make it a little bit trickier and not as straightforward, because there is so much room in that collapse area from post-2018 where it could fill cracks and voids, as was documented by gravity changes in the 2019 era or so. So that's the earthquake story. And there is you can see that last couple of weeks right there corresponds to this high point, this high slope of the graph. When we're looking at this a couple of weeks ago and looking at that one data point that followed the intrusion, it looked like I might have been dropping down, like I might have been doing one of these little wiggles here, but you can clearly see that was just a little bit of, it might have been a temporary and short-lived, because it's resumed that longer-term pattern, whether that was noise or just like a adjustment one way and the other way back within that couple of day time frame. In either case, it's back to its usual swelling, right? Swelling from north to south. across the caldera there. And we'll look at this signal on the summit a little bit closer in just a second, but just to emphasize once again, here's a rift zone signal, and on a rift zone, north to south across middle rift zone at Pu'u'o, still contracting. Nothing what's happening on the summit is making it even to Pu'u'o area on the rift zone right now. That will change someday, but it's not happening now. Okay, so before I move on, let me just switch to the GPS, and I know we looked at this in more detail last week, but we have a little bit more data coming in. These are now 2-year plots, so it's extra squished here at the right end, what we're looking for. But first, let me just recap how these work. These are 3 panels. This up here is the east-west signal, so if this thing is going down, it's moving west instead of east. If this thing is going up, it's moving north instead of south, and the very bottom panel is the vertical uplift, up and down section right here. So I find it fascinating because we're looking at that signal is between Uikahuna and Crater Rim, which is a signal that I have kind of down over there. But zooming into Uikahuna, you can see here that in the last bit of data, which is just right in here, it does not seem to be rising very much. It seems to be stabilized in its vertical. And if I go to the Crater Rim, well, let's just go southwest. We're going to go counterclockwise southwest. We're also not showing a whole lot of uplift here as well, and maybe some stabilization in the signals in the north. East really didn't change a whole lot. Here's our Crater Rim. That's our other end of the line. Crater Rim in the south is moving up, right? This is why I said earlier that the signals seem to be a little asymmetric. So in the south part, where we're seeing all the little earthquakes, is where we're seeing more of this rising uplift of the ground as well. Still moving to the south, although a little slower than it had been prior to the intrusion there. And the east-west signal still moving to the east a little bit more quickly. The one that's the most dramatic is this one at Byron's Ledge on the east part of the caldera. This is the one that we saw being pushed to the east. This upper panel is an east-west signal, so this is actually showing how quickly it's being pushed eastwards. That's how quickly it's being pushed northwards, not as fast. And then this is the vertical signal here, and this is the one that's the most interesting to me. This is the only one you see anywhere that actually seems to have a little offset. I wish I could make this a little bigger. This is a max that I can get in this current setup, but it seems like you had your signal down here, and maybe it was coming like that, but it seems to jump up and then stabilize, something like that if I could draw it, right? It's almost a little bit of a gap, and last week it wasn't quite clear if all this up here was just noise in the data or exactly what was going on, but it seems like there might actually be an offset right here. And in that case, this may be the localized signal of where that intrusion might have occurred. It might have been somewhere over here on the eastern part of the caldera. And that's kind of towards Kīlauea, for example. Maybe not quite under Kīlauea, but in towards that direction. And that's where we don't have a topometer to really show that larger signal like we had in the Southwest Rift Zone last year. So we'll have to wait for more information on that still. But it does seem to be giving us multiple clues that south side of the caldera is the one that's doing the moving now. Right? And I won't go through any of the other GPS signals outside of the caldera, but nothing else is showing that signal quite like that. So that's why it's fascinating, worth pointing out one more time here. Okay, so to go back to the monitoring signals here and finish them off, here's our SO2 from the summit, and they actually have on here plotted this newest data point down here in a 150 tons per day range, more or less. And this is dated from the 21st of March, which is interesting because if we actually come back to the update up here, it does say the last emission rate of approximately 321 tons per day was measured on March 21st. So something is off there. Something's wrong, whether it's 321 or it's this other plot here that we see where it's actually somewhere around 150 or so. In any case, those are both low values. We were looking at values in the thousands before everything backed off, and really anywhere in a range of 200 tons per day to 350 might be background for Kilauea, depending on what's happening underground. So certainly low levels of gas coming out. This for the volcano, relatively speaking, this is still something that would break the EPA guidelines if it was a factory, right? So it's all relative, of course, but still something to be concerned about if the wind is blowing it over your house in particular. We're still having too much noise in the lava depth for the last month, but we're not really expecting to see much changes. If we had seen this more zoomed in, what we saw after the last couple eruptions was the crater floor does seem to kind of sag and cool and contract a little bit as a gas is vented from there on a very, very small scale. So we can't see any of that with this noise of the rain. And what's happening is this is like a laser that's pointing at the ground over there. So when the cloud comes in the way and with a lot of moisture in it and water droplets, and it's getting a reflection there, it thinks that's how far it is the cloud right in front of it. Then the cloud passes and it goes back to normal. So that's what you're seeing here. This is the noise of the laser hitting that interference in the air there. I'm not quite so sure what could make it go the opposite way here and go below. So there's certainly something weird going on. Clearly data went out afterwards, but yeah, it's been an issue with the weather and instrumentation recent month here. And to tilt once again, just to bring us back where we started. So that is all the monitoring signals, and kind of ties up why we think that the volcano is primed that it could erupt again. It could pressurize even more. It's all looking like it's going to do so at the summit, or near the summit, in that upper rift zone area potentially. But even that's not convincing at this point in time. Maybe south of the summit as well. So we're going to get to the map here, but I see Dane has got a couple questions. Maybe we can throw in right here, since it might seem to fit. We're talking about tilt meters.
Yeah, sure. Richard was asking, can groundwater flashing into steam underground be enough to affect tilt?
If it's flashing to steam, yeah, I mean, I think if you were, yeah, I mean, it seems like it could. I mean, those tilt meters are very, very sensitive. I mean, they're actually calibrated to a lot of times to filter out the tidal signals, which they would pick up, and sometimes we don't filter them out as well, like Monoloa. You can still see them. But yeah, if you had a whole lot of rain, the weight of the water could affect the tilt meter. And then if it's actually moving differently because of the steam component, then maybe that would change it as well. But
right,
we find it hard to pick out like the steam versus just rainwater in the ground. The difference, it just seems like it's all down there and affecting the ground as a whole, right?
And it's
a larger mass.
The tilt meters are just so sensitive too. You also can be impacted, by the diurnal cycles, just day and night, and even the wind can impact the things, right? That was one of the more surprising things. So yeah, strong winds too. It's like, well, a lot of these things are overlapping too. So you have multiple things happening. Like if it's storming, windy, it's rainy, and all that, together. Yeah.
So good question, Richard. I think, it probably could, but we'd have a really hard time picking that out as separate from anything else. Might be the best answer I can give.
All right.
So
and,
let's see.
Just throw it in there. We do have a couple of aftershocks on Monoloa falling that now revised down to a 3.9.
All right.
But yep, still keeping an eye on it.
Yeah, and what was that, Kenny? Is that what Kenny's talking about when he's asking about
Yes, that is. I think he's talking about that. We talked about that Singer Kauai, the type earthquakes
Kauiki.
In these areas. Kauiki, and several other, or two other areas. But could this be that signature quake? That was the question.
It's in that area that we've seen activated. I mean, this area activated up to a year before we saw the eruption in Maunaloa, right? And we had some ideas that maybe that area was starting to show signs of leading to that signature earthquake. I think in the literature they want it to be a magnitude 5 or higher. And so a 4 or even a 3.9, that's a little too low.
Right, and even
but it could lead to that. We'll see.
Yeah, even the 5 that we had in before the Monoloa eruption, that one was thought to be too small, right, to be one of those kinds. Yeah. So they're just generally thought of as bigger earthquakes, in my opinion.
Right. So no, maybe not quite right. For reference, I want to say that the one that occurred in '83, prior to the '84 eruption, might have been like a 6-pointer, right? 6. What was it? A 6?
That's the range. Like a 5.5, I'd be like, 6. Oh yeah, that's game. But below a 4 or even below a 5, no.
Right. Interesting though. We'll see if it leads to something else, and we haven't seen one quite that big in a while, so that's interesting.
And it's always, that's one of the things that's interesting about that signature quake from the Maunaloa eruption in 2022 was that we didn't count that 5.0 that was down in Pahala that we connected to Maunaloa. We didn't count that as the signature quake then, but in hindsight,
Well, if it had been a signature quake, that would have been one that would have been associated with a southwest rift area potentially, right? So that was not it, since we had a northeast rift
not
eruption.
it. Right. Okay.
Yeah. So kind of hard. We're trying to pattern match with not a whole lot of data. That goes back only 170 to a couple hundred years now or so, right? So yeah, that's really tricky, and sometimes it's more clear after the fact than during.
Right. That's why it was worth revisiting.
Yeah. Well, thanks for those questions, guys. We'll get back to Kilauea here, and what I want to show you guys next is the reference map that came out from an overflight on the 14th. So March 14th, we had finally enough good weather, and USGS went out and did their usual flights, drone flights that they then take all the imagery, that they do structure from motion, construct a DEM of the area, and then they can calculate volumes and all of that. So as far as the extent of the flows, it's nothing too surprising there. Everything is crusted over now in this pinkish color, and then the yellow is what is the higher ground was not covered in the last couple months here since the start of 2023. So that's the 2022 eruption. Is what you're seeing, those little bits of sticking out. I like to always scroll down here to this little box that tells us the statistics. So here are official statistics for 2 months of eruption. We had, this is the most important number to me, 16.5 million cubic meters, or 4.4 billion gallons is what came out of the ground. That equated to a rise of 13 meters, or 43 feet. So not nearly as much as we've seen in previous eruptions, but now we're at an even 900 meters above sea level, or 2953 feet above sea level as well there. All right, the extent is still just under 300 acres at 292, or 118 hectares. We didn't really have a whole lot of incremental in-between data points for here, but this is the kind of the end result. And that still tells us quite a bit. So let's put that in some context for you guys here. First of all, show you this plot, which is a comparison of the last 3 eruptions. We have in this lighter blue, I'll trace it out here. My tracer is going to be red, but this is the 2020 to 2021 eruption, which ended at 41.2 million cubic meters. Then we had our 2021 to 22, which is this purplish line that I'll trace. It goes all the way up to here. That ended at 110.8 million cubic meters. Maybe I'll zoom that in and pan it around so you can see there's 110. We had that little wheel at the end with that sub-summit intrusion, and you're kind of stalled right in those last few months as Maunaloa really kicked in right around there or so. But so around 110, 111 there. Pan it back around. There is our 41.2 right there from our first 2020 to 21 eruption. And here we are now with our most recent one, 2023, only made it 60-ish days and only got to 16.5 million cubic meters. That's a huge amount of lava, don't get me wrong, but in relative to the other 2 eruptions, you can see this really was a small one. It seemed to have turned over, right? So the lava effusion didn't last at the highest rate for quite as long, right? We ended up over here. We're not quite sure the detail of the in-between here. Is a straight line is probably not exactly how it went, but that's our data gap. You can still tell that it didn't do anything crazy like go all the way up and down. It had to essentially flatten out more or less, right? And there we are. So this is interesting. That kind of fits in with observations early on that we saw the whole lava lake that covered the crater floor entirely didn't last as long as eruption it has in the previous ones. The previous ones has lasted a week or 2. Ours lasted a day. And then we saw the vents changing, and it seemed like the crater floor was still uplifting, but it seems like there's a lot of stuff on top now, and maybe that's part of why it's not getting out as easily, and why this eruption was ultimately not as efficient as the last couple that we had. So interesting to note that volume relative there. I thought I would put something together for you guys to help you understand how much has been filled in here. So I'll have to kind of talk through this with some caveats, but what I'm looking at is Kilauea's inner caldera volume, right? This is a hole that formed in 2018. So the recovery of that hole post 2018. Okay, so first I'll just talk through it, then I'll give my caveats afterwards. Of that full volume in that inner caldera area, by a DM analysis, I find that it's about 510 more or less million cubic meters of area that's there. And so of that, our 2020 to 21 eruption, which was our 41 million cubic meters, is 8%. of the volume that we lost in that inner area that we've recovered. We've recovered 22%. That's our 110 million right there from 2021 to 22. And up through March 2023, because this year may reactivate again, seems likely, but through March, only 3%, right? That's volume, right? The total volume there. And remaining 66%. So you might say we're 1/3 of the way to refilling the hole in the middle of the collapse pit there, right? Now, why I say inner caldera is because if you look at the USGS reported collapse volume for 2018, it's actually 825 million cubic meters. So I'm missing a whole lot of volume. But really, the whole edge of the caldera, the whole ground sagged everywhere. It wasn't just in the inner pit where it collapsed the most. There's a whole underlying structure underneath everything that sagged down. And you really need a DM of the whole summit area as a whole to then compare the before and after to really get a full value of how much has come back into the volcano since the collapse. What I'm not counting here, what I can't count in here, is intrusions, right? We know we had intrusions in December 2020, we had intrusions in August 2021, September 2021. We hadn't had it in December 2022 or September 2022. I can't count any of that. We don't have volumes for any of that individually, right? To add to our pie here, right? So we're looking at the smaller pie of just a collapse hole. So this is more if you're worried about, interested in how much it's filling in, right? If you're actually trying to do more serious volcanology and more and harder science, you really would like to have full DM of the whole summit area to compare to the 825, how much it's refilled since then, including the filling of the hole, but also the swelling and inflation underground. That's a broader area that we can't quite capture with this really crude estimate right here. So, but there's a crude estimate of how, roughly how much. If you're wondering how the hole is filling, this is totally defendable in inner caldera area, about 1/3 of the way as far as the volume goes. That's different from the depth, right? Here's a cross-section we got from USGS last month. So there is the collapse base from post-2018, and here in this magenta line right through here is how far we've come to today, March 2023, with the blue line being water in 2019. So really when we're talking about refilling with lava, we're talking about this black line being that first phase. This is the phase 1 at 2020, 2021. 2021 to 22 is this middle phase right through there. And then really between this red line and the magenta line, that's all that we had in 2023. Still, that puts us, I think I calculated at 72% of the way back up to the previous elevation of the floor of Halemaumau. So it's coming up quite a bit. And as far as refilled depth, it's refilled most of its depth already. But as you can see here in this cross-section, the collapse zone has this big eastward wing to it right here, right? So to get back up to really the full volume across the whole caldera, you got to fill that whole area in as well. And we haven't done any of that yet. And that's why we're even up to the rim of this inner pit is only 1/3. The other 2/3 is this upper part that spans all the way across there. And so we've increased quite a bit in depth, but in volume, not nearly as much. And that's worth clarifying for everyone here. One last one to show you guys as far as this goes. It's a little bit harder to tell. We don't have as good data, but once again, all 3 of the eruptions. And in red here, this is eruption rate as far as instantaneous rates. We don't have quite the detail. We know the eruptions come out with very high fusion rates at the start. The last 2 went up to over 100 cubic meters per second, 110, 129. So it's very likely that this one did as well. We don't have that resolution yet until the USGS reports it to us or someone else. But we do know that it was high at the start, came down, and then ultimately petered out as well. And so you can see the difference here is that we didn't actually get to anything super low. It's hard to tell exactly. We don't have the resolution here, right? And if you count this ending, let's say in February 17th, when we saw the big deflation, so you might be more like around 2 or so, but following the same overall pattern, the story really is it didn't last as long. It didn't tail off at that low rate for a long time. It just got to a low rate and then shut off, which is a little different from before as well. That's just an observation to put out there, and we'll see what the pattern, if the pattern really is changing. We had a question from Zoe yesterday. Dane, I don't know if I have that one here. Maybe I can find that and throw it up here.
Yeah.
Right. So yeah, I'll throw this in here right now. There it is. And Question from Zoe, who says that she is in the wrong time zone to watch this live, but we appreciate you watching anyways. Mahalo. And here we are. Are we seeing, here's the question that I like. Are we beginning to see a pattern of short breaks punctuating eruptive episodes? And that could well be the case. And we really only have one example now here to go by. But if we see it pop up again and then last a short time and then break again, then that could well be the case. And it wouldn't be unexpected, seeing as we have all that stuff above it now, right? The lava's going to come up and push through all that puddle of lava that's crusted over in there. Or find another way out that's easier out to the side. In any case, that's certainly possible. As far as how soon will it be to the next lava breakout, well, we could start a pool again, Dane, but it's anyone's guess. I've seen some people think it's like less than a week, some people think it's more than a week. I'm going to go with, I don't know, 1 to 2 weeks. It might be as long as a month. Might be my guess.
I went with a month, as of a couple days ago. Yeah.
Yeah. So yeah, interesting things to think about there. Cool to note that. And that's Kilauea. So maybe we can check in on our earthquakes once again now. Put those back on a screen here, look at our earthquakes, and we've kind of covered the overall larger picture. So we can focus on Maunaloa now. And let me zoom in so we can have just a listing on here. So there's our 3.9. It's revised to just under 4 kilometers depth, so it matches pretty well with the one we had yesterday. That was in a similar ballpark. That one's at 6 kilometers, 2.5. And several small aftershocks. That's not unexpected here. 2.4, 2.0, 1.5, and this one down here, 2.4 as well. So certainly some adjustment happening on this, just on one flank. One thing that I would point out is it's asymmetric, right? If there was, this is not what's happening, but if there was magma coming into the rift here and pushing outwards both directions, you'd expect it to be quaking on both sides. And in fact, we've seen in the past that Maunaloa has often had a big cloud of earthquakes here northwest of the summit when it's really pressurized to that level. So that does not seem to be what's happening to me. This seems to be more of that adjustment of that south flank to whatever is happening in this upper northeast rift and the summit area here as well. Only time will tell. We'll see. But back to Kenny's question there, I don't think that this is the one that's gonna warrant up a big one coming. We'll see more signs if that were to be the case. And if I were to guess Monoloa, I would say at least a year, at least.
Yeah, I'd be going even long on that.
Yeah,
but
that's a minimum. Yeah, we can make some arguments. Yeah.
The timing of the signature quake is also important. It's not just like, oh, we had a decent sized earthquake. Just there's all kind of in that building sequence to everything, right? And we're not exactly at that, and at least to me.
Right. Yeah.
It could build into it, right? But it ain't it.
Yeah. One of the reasons we look at the earthquake counts graph is because it's not only the size of the earthquakes, but the number of them. So sometimes having many small earthquakes is more convincing than having one big one. Like one big one can happen just from adjustments, and one big one can lead to aftershocks that are smaller. But if you have lots of small ones that kind of keep going and never stop, then that's telling you that there's an ongoing process. It's like still pushing from magma. In that case, it's usually magma breaking rock underground. So that's not what we're seeing at all. It's more of a, I would still say, an adjustment post-eruption there, south of the northeast rift. So those are the recent earthquakes. We'll keep talking about this over time, but probably no point doing any more of that today. Let's move to Monoloa. And there is Maunaloa's tilt signal. At the top, you see those diurnal day-night variations that we've discussed here. Here is the last month. And I think over the last month, we've in the past thought, wondering if this upswing might be part of some larger seasonal cycle, something like that. But it's stayed going up for several months now, right? With some small offsets from weather and possibly some snow cover on there. So it does seem like it's filling in the summit area, but really it's the lack of earthquakes that makes all the difference. The GPS is still offline, not transmitting, so nothing to see there. But here is the earthquakes at the summit region, which is really not a whole lot. You might see a couple dots in here. If I maybe zoom it in more, you might see a little better. That smattering of south of the caldera area as its south flank is still the one that we believe is the mobile one here. So that's all normal background, just showing that it also moves in its background state. So earthquake counts, it's the whole last month there, and earthquake rates, month, year, once again there, and this is really the convincing data that there's not anything major happening there, right? So in the last 5 years, and relatively speaking, you can see really the earthquake levels. I said it was the lowest point in at least a year. Here you can see that it's the lowest point in about 5 years or so, right? Really since 2018. So that is the Maunaloa signals. We will continue now with our Volcano Watch. Volcano Watch from both this week and last week. Let's start with this week's. This week's starts off talking about Pele's hair and about how that was something that was noted island-wide during the Monoloa eruption. So they have on here a photograph at high resolution. This is 750 micrometers scale right here, 0.03 inches wide, and showing the Pele's hairs with little droplets of lava. You can really see how the lava transitions into the hair. It's really like the lava getting stretched out and then freezing in that long filament kind of form. That's what a Pele's hair actually is. And they're so thin that you get them to be a little translucent and have this golden color. So this Volcano Watch is interesting in looking at the hazard of Pele's hairs. Clearly, it's a nuisance if you're around an eruption. You definitely don't want it in your eye. You don't want them in your hands, and even gardening around in volcano areas afterwards, you might get them in your hands if you're not wearing gloves, just from being in the ground for years and years and years. They can get to be over 3 feet, 1 meter long, and are often less than a millimeter wide, thick, wide, 0.04 inches. They noted them up at a visitor center in Mauna Kea, all the way to Honoka'a. We heard Lapa Hoi Hoi. We heard Captain Cook as well during the Maunaloa eruption, right? Of areas where Pele's hair was falling from that fountain that was coming out at 11,000 feet and getting carried by the wind. And that's really one of the key forms, key characteristics is it's so light it can get carried a long distance by the wind. It's interesting how they note that this is lava texture that's fairly unique to basaltic volcanoes, because other volcanoes, the lava is much thicker and more silicic, stickier, and so it doesn't actually stretch out so well. It'll freeze and crack and break, or it'll just do something else rather than stretch out like that. And even in Hawaii, you have to have just the right kind, temperature and conditions of lava. So not every chunk of lava can actually become a Pele's hair, but when you have something like a fountain or a bubbling lava lake, then you have somewhere in that environment conditions that can actually produce a lot of that Pele's hair, which then gets blown around and collects in the downwind areas and the cracks. Here's a picture that they have of the Halemaumau parking lot before it collapsed into the crater in 2018, with all this deposit downwind of Pele's hair. And if you were able to walk out in the Kau Desert, there's still tons of the stuff all the way out there. So that's kind of the first part. I'll talk about the second part here in a second. What do you got, Dane?
Yeah, I was wondering, we were seeing collections of the Pele's hair down along the lava channel, and the question I had was that could it be produced by the lava channel itself, interactions with the wall or something like that, or
Exactly.
is that blown in from other areas, or a combination of the two?
It could be both, right? But yeah, I mean, there are videos from the early eruption updates where you see the lava channel, and like there's a piece of rock that sticks into the channel, and the lava gets globbed onto it, and then it gets pulled, and you can see it stretch out and forming a Pele's hairs, and Pele's hairs just kind of keep flapping in the wind attached to that point. So that's definitely something that can happen. But if you have a whole bunch of them, like what you see in the photograph here, then it's more likely not that, right? Because to generate this kind of volume, you're going to have like a lot of bubbles and lower fountains happening. You have to have a lot more chunks getting pulled apart all at once.
Mm-hmm.
Yeah, and notably, this area of Halemaumau was downwind of the lava lake for not quite 10 years, I would say. I mean, the lava lake wasn't that high enough that you could see as much, but for many, many years did it do that, and that's how you get this big of a deposit. This picture's from 2012, so you might have had, this might be, call it 3 years of accumulation of Pele's hairs down in that parking lot there. And this is now, this whole piece of land is just in fragments on the south side of the collapse pit now. So that's the kind of what Pele's hair is, and there's, you can read it in more detail on hawaiitracker.com. But they also go into here to talking about classification of different kinds of tephra, right? So tephra is a family that includes all solid particles flying out of a volcanic vent. And they note one of the most common ways to classify tephra is by grain size. For example, ash is defined as tephra particles that are smaller than 2 millimeters. Lapilli are defined as particles between 2 and 64 millimeters. And larger than that, it can have two names. It can be bombs if it's from fresh magma, or blocks if it's from pre-existing rocks that were blasted out. So if you try to be that rigid with your definition, then Pele's hair gives you an issue, because in one dimension it's longer than 64, in the other dimension it's smaller than 2. Right? So what is it? It's actually not either ash or a block. It's got different properties. And I think more than anything, this shows how the nomenclature, like all the terminology, can be useful as a starting point. But when you get into the nuts and bolts of how things actually work, sometimes that just breaks down and you have to kind of just put it aside and say, well, it's a Pele's hair, it acts a little bit differently. So if you want to see how they conclude that here, you can go and read the article. That's a little bit of the interesting things about Pele's hair here. They have a hard time forecasting them with dispersal because of this asymmetry they have being so long and skinny, right? So that is it for this week's Volcano Watch. But last week's came out after we had concluded our program, so we'll bring it up here as well. This is interesting. This is Geospace, the benefits of accommodation and inclusion in geology field experiences. So this is focusing on the Geospace, which stands for the geoscientists promoting accessible collaborative experiences. It's a field course for geologists that takes place simultaneously in the San Francisco Volcanic Field in northern Arizona, and online as well, right? And in case you're not aware, if you're going for an undergraduate degree in geology, quite often you have a required field course component. They can be 6 weeks long. The one that I went to was 8 weeks long. And it's a chance to understand field relations, practice all your skills, and generate products like maps and things like that, right? Cross sections as you go through that area. So what's really interesting about this is, it's designed to be accessible. So you have 2 different teams. There's a team that's out in the field, and that team that's out in the field is taking field measurements as directed by their mission control team, which is seen here during one of their meetings, during one of their daily Zooms that they would have, right? So, and this is interesting because this is the same model that's used for NASA, let's say, right? Or, it's something that as we even now, like when we have scientists, for example, we talked about last week, there's scientists going and landing on a caldera floor and that little island and sampling. There certainly was a mission control team back at the observatory monitoring all the signals and ready to radio in case they saw something unusual, right? Oh, here comes an intrusion, everyone get out of there. That happened the next day. But there's always someone who has to watch from a base to help with the project there. So this is fascinating. It's really, really training people to take that mission control role, right? I think those people are actually going to be at an advantage in these situations, right? We talk about how everyone deploys from the mainland, and all these USGS is a national organization, so it's got all these different layers of contributions, and really fascinating to see that you can actually. This is new, not something I did when I was an undergrad, right? To have this whole dual nature of designing, analyzing the data that comes back overnight, potentially, right? And then in the morning, drawing conclusions from that and realizing what you're missing to then direct the field crew to go out and find the missing bits that you need to kind of finish your information. So yeah, interesting. That's something not too unlike 2018. We had some parallels there as well, right? There's a lot of stuff. Yeah. What do you think, Dane?
Yeah, I mean, that's how we were doing operations 2018. Just the field crews, they're really good at the spot that they're in, right? They're like the expert of that one area, but they can be completely oblivious to something happening 4 blocks down, right? So you have to have this network of people on the field in different areas to be able to really do those types of real-time monitoring. And sometimes that becomes exhaustive for, many organizations. So crowdsourcing is great in that regard.
Yeah, and that's really what Hawaii Tracker was born from, right? It was this exact kind of process. So awesome to see it integrated into training here. Awesome to see that the courses are more accessible, not just for those who have mobility issues, but also those who might have caretaking issues, right? Have families at home or small kids and actually can't commit to 6 weeks in living in a tent in Arizona, right? You have other life things you got to do. So it's really there's a role for anyone really, right? That can come in, and I think everyone who's watching us on the internet understands what the power of that is and how we can all be working remotely and connected that way as well. So really awesome. I was glad to see this article come out, even though it's a little bit different from what we usually see. Still really cool here, to note this, right? So here's a quote from a student, Frankie Butler, a student at the University of Aberdeen in Scotland, stating, "The geospace field trip was a truly transformative experience. I thought my lifelong dream of being a volcanologist was over after my devastating injury. I missed out on 4 years of field work and had no access to that unique learning environment. I was treated as a scientist. I was part of the discussion. I got to see a real HVO volcanologist in the field. As an undergraduate, you don't get the opportunity to see working scientists in the field. Seeing their systematic approach to an outcrop and the techniques utilized have helped me become the field geologist I am today." So really awesome. I'm sure HVO was super proud to have that kind of feedback. And in case anyone is a geology student and having issues with their field experience or knows anyone in that category, then looks like Geospace is an awesome program to look into here. So that's both of our Volcano Watches. This is last week's, and then we'll talk about the one that was this week's as well. So only a couple of final community points to cover for you guys here. One relating to Maunaloa National Park has put out a release that the Red Hill cabin, and the trail to the cabin, is reopened. Only to the cabin, not above it. I'm sure everyone that's looking at this is thinking, oh, right above that is where the eruption is. And yes, not quite right above, but this is a first step towards making that eruption site accessible at some point in the future, I would hope. But for now, the trail that leaves from around 6,000 feet, and then I think Red Cabin is somewhere in a 9,000 foot elevation area. So it's 7.5 miles up there, and it's a place you'd stay overnight on a way to trying to summit Maunaloa. That cabin is reopened, and because everyone's going to think the same thing I just mentioned here, they do note here that serious hazards still remain in enclosed areas above that cabin, including sections of trail and trail markers covered in new lava, increasing the risk of getting lost. Thin layers of solidified lava that can collapse if walked on, causing lacerations or injury by falling in the cavity. This is really true. Closer to the vent you are, the more gas-rich the lava flow is, and so the thinner the crust, and more easily you fall through. Dana and I were just earlier today up on Ahu'aila'au area and Fissure 8 from 2018, and seeing all that same pattern of really bubbly lava closer to the vent with really shelly stuff. You want to be real careful walking around. Also, those areas are easy to get lost because the area is high elevation, has poor weather, poor visibility. So also delayed response time. And the other thing that I would throw in here is high altitude, less oxygen, so our human brains don't work as efficiently. We sometimes make bad decisions. Right? So this kind of place you don't want to be getting lost and having to figure out where you're going because you don't always get it right. And finally, localized pockets of volcanic gas and particles. Yeah, go ahead, Dane.
Sorry. I was going to say, and so do rescue helicopters. Trying to get one up there and do something at that altitude, good luck. Right? It takes a very skilled pilot. So yeah, this isn't like being near a roadway that you bust your stuff, you jump in the car and, go take care of it.
Yeah. So the last point is localized pockets of volcanic gas and particles remain and present danger. They say face masks do not protect against gas or particles. I would say not necessarily. Definitely not against the gas. Particles, depending what kind of mask, maybe. But in any case, you don't want to be putting yourself at that kind of risk. And I would just urge everyone to just remain patient and be hopeful that this is a sign that they will reopen that trail to that eruption site at some point. And it might take a while for them to reestablish what's safe up there and all that, but clearly they've reopened to Red Hill already, and that's a positive, I'd say. So that's our first community item here. Red Hill is actually at 10,000 feet elevation here, I'm seeing now. So if you're going to stay overnight, you do need to register with the park, backcountry permit, check the park website for all of that. So that's the first point. The second thing to mention is here that we have still open the public input on the USGS facility in Hilo. The in-person open house has come and gone. However, the online review period is open for another 5 days until March 28th. So if you're interested in contributing to the process to the site in Hilo, then that's still possible for the next 5 days here. And the last thing to mention is this upcoming 2 days from now, Big Island Press Club Newsmaker Luncheon, of which we'll be taking part. So this is a luncheon that we're going to broadcast live with the help of Two Pineapples, Mahalo to Pineapples. It's going to go on their channel as well as in our channel. Where else, Dane? Big Island Press Club as well.
Yeah, their Facebook.
And so this is going to be 11:30 a.m. to 1:30 p.m. on Saturday. And it's going to be kind of a Q&A talk story session, right? And on the panel is Dr. Ken Han, scientist in charge of the HVO for the USGS, Talmadge Magno, Civil Defense Administrator for Hawaii County, Jessica Fairkane, like affairs specialist for the National Park, Chris Leonard, President, General Manager at the New West Broadcasting Corporation, which operates 5 radio stations on the Big Island, as well as Dan and myself, who are representing Hawaii Tracker. So the idea is to offer insights on a recent eruption and lessons learned, and media coverage of it as well, that can be applied to future disasters impacting the island. So there were tickets in person. It's all closed for sale now. So I imagine if you guys are watching us online now, you probably can watch us online on Saturday or whenever afterwards is convenient for you. That is our community corner here, Dane, and I will turn it over to you.
Right. Well, I want to thank everybody for tuning in today. We rely on viewers like you to help share this content, get it out there. So like, subscribes, comments after the video ends, all that stuff definitely helps, and we appreciate it. We do want to thank the County of Hawaii also for their support through the ViVi grant program to help bring this content to you, as well as some of our written content that we share on Hawaii Tracker and on the Facebook group. We did have a couple super chats. Want to acknowledge those real quick. We had longtime supporter Gary Bryan come through with a $35 super chat. Says thanks, Phil and Dane, for these updates. We had a $20 donation from Subi, and we had a $20 donation from Lisa Lynch. We appreciate all of those. Appreciate your support, guys. All right, I think we got through the questions, as we were going through the whole thing. We did not hit the target of 1 hour and the so-called short stream. I'm starting to think it's a myth. It just doesn't.
It's our running inside joke here, right? Everyone will know that that's just what we always say. We can never deliver on that.
Yep. So unless something happens, we will be back next week at 5 p.m. That is our standard time, 5 p.m. Hawaii Standard Time, to go over the latest on Kilauea, Monoloa, and anything else that goes shaking the day. We will see. It was interesting to have this earthquake pop up just as we were pressing the live, or we already pressed the live button. We were waiting for the pre-countdown delay to end, and the earthquake hit. So that's always interesting. Yeah, but until next time, aloha from me.
Yeah, thanks, Dane, and thanks everyone for joining in and participating in the chat and every week with your contributions verbally, and those of you guys who are also supporting us with donations. We really appreciate you guys as well. Until next week, from HawaiiTracker.com, he's Dane DuPont. I'm Philip Ong. Aloha, everyone.